Hi everyone, I'm Sajjad. Today I'm going to present a scalable, resilient, and configurable permission blockchain fabric. This work has been done with Suyash, Thamir, Jelle, and Mohammad in Expo Lab at University of California, Davis. So what is blockchain? Talking about blockchain, the first thing that comes to mind is cryptocurrency. Bitcoin, Ethereum, and Ripple are the examples of widely used cryptocurrencies. If you are a little bit more familiar with blockchain, the second thing that comes to your mind would be distributed ledger, which is a list of chained transactions which has been written to the ledger and distributed across multiple machines or nodes to provide secure and democratic way of ordering and running transactions. Bitcoin and most of the most of cryptocurrencies are permissionless or public blockchain. There is another type of blockchain which is called permission that we are going to compare with permissionless or public. In permissionless environment, the identities are no nodes or replicas are hidden for each other. So they do not know the identities of the others or who is sending the transaction. They are computation based, which means they are trying to solve a mathematical puzzle, and consequently they are energy limited. In contrast to public or permissionless blockchain, in permissioned, everybody knows the identity of the other participants, and everything is communication based, and everything is being done through message passing, and consequently they are network bound. Most of permission blockchain system are based off practical Byzantine fault tolerance or PBFT, which is a consensus protocol to order transactions. The flow of that protocol is being shown in this slide, which, as you can see, the clients send a message to the one of node which called primary. The primary broadcasts that transaction to everybody, and there would be 2 rounds of n-squared communication between all nodes and execution and sending reply back to the client. As you can see in this flow, there are multiple rounds of communication, which makes permission blockchains heavy and hard to scale. So what are the design parameters, elements, and components of our permission blockchain? The first one is message processing, because everything is happening through messages in permission blockchain. The next thing would be execution, how we are going to execute the transaction or smart contracts. The next thing would be parallelization, and it is the most important one to get better performance, because if everything is going to be run sequentially, the permission blockchain system would not perform good at all. The next thing would be queuing and user interface and configurability. And finally, and the most important one, would be the scalability, how scalable the permission blockchain could be. Now let's go and talk about our architecture. Our architecture has 2 main parts, interface and monitoring, and the blockchain core. In the interface and monitoring part, we have a web dashboard using Nginx and React that gets parameters and everything from the user and send it back to the blockchain core to run the actual blockchain, and the stats are sent to the monitoring and the statistics part to show to the users as a graph and dashboard. So what's happening inside our blockchain core? Our blockchain core has 5 important parts, which is input threads, batching and consensus threads, execution threads, output threads, and beneath all of these things, our storage layer, which maintains the actual storage, the actual blockchain, or the transactions in DB2 level DB or SQLite storage. So what's happening in our monitoring and statistics? We have a couple of scripts in blockchain core to gather the results and send them through the secure tunnel to the time series database called InfluxDB. And there are scripts there to accumulate and analyze those data to send them back to the dashboard to show to users as a result. Now let's go and see how our system works. As you can see, here is our web interface to run the actual blockchain. There are a couple of parameters that you can change, and there are a couple of more that we haven't adjusted them to our web interface. For example, the number of nodes, the number of clients, how many regions do you want to use? You can use Europe, Asia, India, US, and everything. which benchmarking system do you want to use, banking smart contracts or simple YCSP, how many threads do you want to use, which would be your storage, the signature scheme, your hash scheme, number of requests per transaction, and the most important one, which consensus protocol do you want to use, practical, Byzantine fault tolerant, or Ziziva, and batch size. After you adjusted all these parameters, you click run. The resilient DB will be started successfully, and you can see the logs here. The config file has been created. The code is being compiled. After the codes get compiled, it will turn on some machines on Google Cloud. It will start the resilient DB on the number of nodes that you have adjusted, and it would be 1 minute of warm up. And after that, the actual transactions and consensus is happening. Once you click the data analysis, you can see the throughput and the results of your run completely online on our graph. As you can see, we have nodes here, we have R1, we have R2, R3, through R10, and the clients. And as you can see, we are getting throughput here. For example, for node number 5, we have throughput of 83K transaction per second, and it will run for 2 minutes. And you can monitor everything here. So the next demonstration scenario that we are going to cover is how to create a smart contract in our blockchain fabric. What is a smart contract? A smart contract is a piece of code which executes a transaction in a blockchain environment. We have provided a useful code base that you can just inherit your class from those smart contract classes and just define the execute function of your smart contracts, and in that function you have access to DB instance, which is one of those SQLite level DB or DB2 that you can interact with the actual ledger, read and write to the ledger. Thank you, everybody.